Now, this is the alternate way to solve this problem. If you're not a fan of logarithms and you want to put them off until the very last minute, what you can do is you can use exponent rules. Because log rules really are exponent rules, because logs are exponents. So what I'm going to do is I'm going to break up 3 to the 2x plus 1 into 3 to the 2x times 3 to the 1. This is going to equal 7 to the 1 times 7 to the negative x, because that's the way you break apart exponents. Now this 3 to the 2x, I'd really like to have that in terms of something raised to the x. So I think, oh, this is just 3 to the second to the x. Well, 3 to the second is a more common 9 to the x. 3 to the first is just 3. 7 to the first is just 7. Now 7 to the negative x, that's 1 over 7 to the x. Now, just like in the other problem, I'm going to get everything with an x on one side and everything without an x on the other. So I need to multiply by 7 to the x and divide by 3. So I'm going to get 9 to the x times 7 to the x, that clears the fraction, is equal to 7 divided by 3. Now because these are two different bases but the same exponent, it's not really factoring, but I can take out the common exponent. So this is 9 times 7 raised to the x, and this equals 7/3. And it's at this point where I would say 63 to the x is equal to 7/3. We can now use logarithms of your choice. I prefer ln's, so this is going to be x ln of 63 is equal to ln of 7/3, which is a line exactly from the last problem. X is equal to ln of 7/3 divided by ln of 63, which, as we've already established, is 0.205.